Hey, welcome everyone to our 1:30 roundtable with the National Geographic team on can we map our way out of world water problems? If you haven't been in this type of session before, it is more of a conversational style than the press conference where we have people on stage. So we hope that if you're a reporter in the audience, will come to the table if you're willing, and talk with us, face to face. We are going to see a little presentation from our panelists, and then we'll open it to Q&A. We also have a few people online. If you're online, we're on Zoom meeting, not Zoom webinar. So once we stop sharing our slides, we hope to put your faces up too, so we can see you. If you're willing to turn on your camera, please do so. That's a big help to us on this side. But just still remember that you need to mute your mic when you're not talking, because we will hear you. And with that, I think I'm going to turn it over to Will Thompson to introduce the panel and get started.
Yeah, thanks so much, Liza. Well, thanks so much, everyone, for being here today. Really wonderful to have you all here. So today we are talking about National Geographic's Freshwater Initiative and our World Water Map. Could we hit to the next slide?
Yes.
Come on. So just a quick overview of what we have for today. We'll talk about our World Water Map and Freshwater Initiative. We'll dig into the data behind the map. And then we will talk a little bit about bridging the science and the storytelling. And then we will take some of your questions and answers. And we will answer the questions. My name is Will Thompson. I am a senior manager of storytelling programs at the National Geographic Society. And I'm also really proud to be here today with Marc Bierkens, who is one of our National Geographic explorers and professor of hydrology at Utrecht University, and Dr. Nico Wanders, also associate professor of hydrological extremes at Utrecht University. And I want to apologize. I was talking normally until about 5 minutes before this. So I also, on a serious note, want everyone to know I tested negative for COVID prior to coming in today. So it's just, I think, a little bit of residual difficulty from the flight over here. So being National Geographic, we actually have a short film queued up.
Welcome to the World Water Map, a geovisualization of the world's freshwater. Think of it as a map that accounts for every drop of water in the world and where it's going. Developed by the National Geographic Society in partnership with Utrecht University and Esri, the map takes you on a visual and interactive journey to understand the water gap and the drivers of water scarcity around the world. Test your knowledge. Do you know how much irrigation and agriculture impact our water demand? The water gap and freshwater issues are important to investigate at many scales. Go on a journey to see how the water gap is playing out in your community and around the world. Over the course of the 5-year World Freshwater Initiative program, the National Geographic Society will award grants to changemakers working in freshwater science, conservation, education, and storytelling. Here you can find information about the current and upcoming grants the Society is funding to tell the stories of freshwater around the world. In addition to this map, National Geographic Society is bringing data to life by telling the stories of the individuals and communities affected by the global water crisis. The Society launched the World Freshwater Initiative, a 5-year program to better understand freshwater availability issues around the world and inspire sustainable action. Dive into this water gap dataset, created by hydrology and modeling experts at Utrecht University. You can choose to view water demand or the water gap for different areas. You can also choose to see the entire gap or just the gap by sector, industrial, irrigation, and domestic use of water. This map is a game changer to better understand and mitigate against water issues impacting communities across the globe. You can see this map and more at natgeo.org/freshwater.
So I know everybody has come to expect lions and crocodiles and predation series from National Geographic. I'm sorry, that did not have any lions, but you can go on Disney Plus for that. So a little bit about why we did this. At the National Geographic Society, our mission is to illuminate and protect the wonder of our world. So we're dedicated to studying, conserving, and telling the story of water, because as we all know, water is vital for life on Earth, for humans, and for the natural world. However, as we also all know, Humans' current use of water is compounded and exacerbated by our changing planet, is becoming unsustainable. We're watching as our lakes and streams run dry at an alarming rate. We're depleting our aquifers, tapping deeper and deeper groundwater sources that can't be replenished in our lifetimes. So in line with our mission, and to do something about it, National Geographic launched the World Freshwater Initiative. So the World Freshwater Initiative is a 5-year initiative that aims to better understand developing freshwater shortages around the world and to inspire action to conserve and protect freshwater. Our 2 main areas are the World Water Map, which is creating a visualized global accounting of freshwater supply and demand. And we are also, over the next 5 years, going to be giving out grants in the areas of science, conservation, education, and storytelling to fully tell this story, get it to the people in the audiences who are concerned with it, including scientists, policymakers, journalists. And we are also launching grants in science to understand shortages and solutions, and conservation to enact community-led conservation solutions. So apologies once again for my scratchy voice, and I believe I'm now turning it over to Marc and Nico.
Yeah, thank you. Next
And
slide,
we can-
please. Yeah. This is still some information about the World Water Map.
Oh, I'm sorry, this is
Yeah.
just an overview of our World Water Map. So we did partner with Utrecht University, who's used the past 40 years of their hydrological data to create this map. And the map really amazingly accounts for every drop of water in the world and where it's going. Really importantly, also through the map, we can identify global hotspots. So these are the areas in the communities where the demand for fresh water is most dangerously outpacing the replenishable supply. We can also look about how water is being used for domestic, agricultural, and industrial purposes. And we can also equip journalists around the world with evidence and tools to cover freshwater issues. I actually want to point out a really important part of this. In this lower corner, you'll see a link to the data. So we have made all of the data that goes into the map, so all of that 40 years of hydrological data that has made this map is open source and available for download for journalists to use in their own reporting, and for scientists as well. The best way to get there would just be Google National Geographic Society World Water Map. You'll find us online, and scrolling down below the map, there is that actual link. It looks just like that on the website, and you'll be able to find all the data there.
We can pop that into the notes after the session. It's already in the chat.
Thank you.
Okay, next slide. So yes, I will talk a little bit about the background of why we study the water cycle and its human impact, and then Nico will zoom in into the actual modeling of the water gap and water use by the different sectors. So this is basically how we normally imagine a hydrological system, a nice ribbon, blue ribbon, meandering through otherwise pristine landscape. But if you go and look at most of the rivers in the world, especially near the coastal areas where large cities develop, it looks a little bit like this. So humans have been interacting with water and using water extensively. Next slide, please. So even since the dawn of civilization, the welfare and growth of human societies depend on water. We need it to grow food. Either, directly, it's there for free, which is called green water. It's water in the soil. It comes from rainfall. But more and more, we also try to feed our population by irrigation water. And we have to extract that either from groundwater or surface water. Water is also used for energy provision. For instance, by hydropower dams, but also the cooling of our thermal nuclear and thermal combustion power plants as well. And finally, water is used in the industrial processes, and of course, is drinking water provision. And of course, this has its downsides because of that, at a growing population, we have more and more areas where there's lots of economic development and there's lots of population growth, and we're over extracting our surface waters, leading to reduced stream flows, endangering the ecosystems. And we're also extracting too much groundwater in many places. It leads to the falling groundwater tables and also impacts on wetlands and so on. And of course, all of our, and by using that water, we also pollute it on the way. So there's lots of pollution that actually is released through our water system. So that pressure on water is actually that we want to also take into account. So how much do we need, but also how much pressure do we put on the water system? Next. So this is just an example on how people have been putting their imprint on the water systems globally. This is a snapshot from our model where we see in time the red rivers are rivers that are being impacted by reservoirs and dams that are being built and basically affect the natural flow regime. And you can see that there are hardly any pristine, non-affected rivers left, at least the larger ones in the world. So this is another way on how we affect that. And we try to model all this, and that is what Nico will take over and talk about the model.
Yeah, that's on the next slide. So what we have is a world water model that actually tracks water droplets around the world. So wherever water droplets fall, we try to visualize and compute their journey through the ocean in the end. So they can either go into the soil or they can go straight into a stream, but eventually they reach the ocean via one pathway or the other. And it matters which pathway they take because that really gives us these freshwater volumes for irrigation or for replenishing groundwater and things like that. Now, such a world water model, I'm not going to bore you with the computer code behind it, but what goes in there is actually the next slide. We have meteorological information. Think about precipitation, temperature, but also evaporation. As 65% of the water that falls on Earth evaporates back into the atmosphere. That's important information to have. Now, we also, on the next slide, we have more like the geological information on land use, soil types, geology, but also the vegetation and elevation. Because if it's high, of course, it's going to be snow, and if it's low, it's just very close to the ocean. But I think for the world water map, and that's actually on the next slide, the key things that we're adding here, and that's also what we do in Utrecht in terms of science, is adding that human component in there. Because as Marc already showed, more and more of the global water cycle is no longer natural. So it matters where the lakes and reservoirs are, where we start irrigating, how much water we use, and from which sources we use that water. So that's what we do. And if we put all that information into our world water model, we get on the next slide our world water gap, which is we have information on soil moisture, so how much water is in the soil. We have information on the groundwater. We have information on the discharge, the water in the rivers, but also the water gap. So how much do people want to use and how much is actually available? And that mismatch, that's what we call the water gap. So what we can't meet. Now, if we go to the next slide, these are the components, as Marc already alluded to give you some visuals on what kind of water demands we're looking at. You can think reservoirs, irrigation, industrial, domestic water use. And yeah, those imprints become more and more prevalent in the world. And I took an example on the next slide, which to me always speaks very much. And that's the example of the Aral Sea. So on the left, we have it as it was, more than 20 years ago, was a big sea where a lot of rivers come in there, and it doesn't have an open connection with the sea, but rivers feed that the Aral Sea. But by unsustainable water use in the edges around, we're building cotton for our clothes in an area that is obviously rather dry. So what people used in that area is groundwater. So they use pumped up groundwater in unsustainable rates, basically exceeding the natural water availability, thereby drying out most of those rivers. And currently only 15% of the original Aral Sea is left. And this is quite a visual imprint. And that has impact on local communities. And for me as a scientist, it's nice there that we can then team up with storytellers to see what the impact is on the local communities. Because it's not, if we also look at the solutions, you also have to look at what the people are suffering from. For example, in this case, fishery is heavily affected. So people can't sustain their livelihood in the normal way they used to do. Now you might wonder, where are the hotspots of this place? And that's actually on the next slide and my final slide. These are the 22 hotspots we have identified in the world. And what we've done is we used our model, but on the other end, we also done an extensive literature research from all scientists around the world, looking at does our model and those local studies overlap. And these are the regions we identified. We're very close to one of them at the moment, the Central Valley in California. But also the US High Plains, and we have many across the globe. And the more dark red colors you have, the more severe that water gap is. And there's places in the world where the groundwater tables are declining with more than a meter per year. So that's really, unsustainable in that regard. And I'll close it off and give it back to Will.
Right, so like Nico was saying, oh, I'm sorry, if you could hit the next slide. So like Nico was saying, actually looking at what the data looks like on the ground and how it's manifesting around the world. We've launched our first RFP to fund storytellers, so photographers, filmmakers, data visualization, to look at how these hotspots are actually manifesting around the world. So through that first RFP, we funded 10 storytellers in 8 countries to investigate the causes and consequences of dwindling water resources and to share the stories of how sustainable adaptations and solutions are taking foot around the world. So this is our map of our first 10 storytelling grantees. And we can hit the next. These are just some examples of how the World Water Map has already shown up in headlines around the world and how journalists have already started to use the data behind the map to support their own journalism. And we can go, I think, down to Q&A. Yep.
So the map seems like it directs towards chronic water hotspots. Do you account for seasonality, places where might be a particular time of year where water problems crop up but are not present the rest of the year?
Yeah, actually, without seasonality, most of those hotspots would not appear. So we do that. We basically assess the difference between demand and supply on a monthly basis. So the model simulates at daily time steps or even sub-daily when it comes to simulating the river flow. But we aggregate to monthly time steps and at a monthly, and if you then, whenever there's the supply is less than the demand, we add that to the water gap and we add those gaps, we add those up and arrive at an average yearly gap by that. So the seasonality is essential to that.
I'll just remind everyone in the room, please introduce yourself when you ask a question. That would really help us, especially the people online who maybe can't see you as well. And who you're writing for, if you don't mind. And even our speakers, if you repeat your names when you talk, that's helpful for the folks online too. Thanks.
Retroactively, Brett Walton Circle.
Thank you. You're welcome to just jump in anytime, people in the room as well. Ask some questions as well.
I'm with Marc, National Geographic Explorer. In your calculations, do you account for the already degraded nature of water in some places, say because of salinity or some other contaminant that prevents the use of existing?
Yeah, Nico Wanders, Utrecht University. No, at the moment we really look at the quantity. We have models that can also take account for the quality. But we haven't implemented them. Of course, if there's no fresh groundwater available, there can't be any abstraction, but there's also places where you get pollution underground or salinization or seepage that there we currently do not account for. It is something that is on our radar for, I mean, this is year 1 out of 5. So it is something that's on the radar, because certainly if you go to coastal regions, this is a major influence if you look at things like drinking water or industrial water use, extraction, or even sometimes unsustainable water use there can lead to degrading aquifers in those regions. So, yeah.
Yeah, I'm also thinking more drier regions where there's a bigger demand for water. Those areas can have salinity.
Yeah, that's a good point. So one of our colleagues, Michelle van Vliet, is actually, she defined a water scarcity indicator, and we can actually apply that to water gap as well. Now it's only, you have a lack of quantity of water, but you could also say, what is the gap in having water available at sufficient quality? So sufficient water with sufficient quality. And there are certain quality standards for drinking water, for irrigation water that we could use, depending on salinity, nitrate concentrations, fecal coliform. There are a number of those quality parameters that we could take with it, and actually generalize the water gap issue or the water gap assessment by using these water quality standards. And that is something, this research that is being done at the moment, and will eventually also end up here.
Jess Burns, Oregon Public Broadcasting. You talk about the data being available for journalists to use. Are the visual assets and the data visualization that y'all put together, is that also usable by journalism organizations? And is there a way of getting that?
Yeah, not at the moment. At the moment, it's just the data. We are going to launch next year what we are calling the experts map, which is going to be a more in-depth look about how the data compares. And it's going to be more geared towards journalists, scientists, and policymakers, while this one's more geared toward the general public. But I'm not sure that even with that one, you'd be able to take like the entire map graphics. But it will help really tell more specific stories. So you were looking for like the actual mapping
Yeah, I mean,
graphics.
journalism organizations don't often have the firepower to produce
Yeah,
this level of graphic.
the level of graphics.
visualizations.
As it is, it's only the data behind the map, but next year we're going to look at expanding how we can support journalists more readily through the World Water Map or through the experts version. So we'll definitely take that into account.
Yeah, that gives you a little bit more direct means to make your own visuals
Right.
based on the data, because now really the data are there, but they're not CDF, I guess, or not.
Yeah.
So that's mostly a format where scientists work with, and so that it's sometimes a bit hard to handle. But then what we would like to have is a more expert website where you can actually click on or maybe select an area, get the underlying grids also, the gridded data, and maybe compare two time slices, look at get country statistics, look at trends, and also visualize that in an attractive way. We're thinking about making something like that together with, basically we provide the data, and National Geographic does together with Esri does the visualization. And that would, I think, help you directly make these visuals online. And that will be, of course, very helpful.
But if you already want access, we can extract that stuff. So just send an email or whatever, and we can get the numbers behind.
Yeah.
For specific locations.
Yeah.
Maybe, oh, I'm sorry.
Question. My name's Jillian. I'm a graduate student at University of California, Santa Cruz in science communication. And I was wondering, when you're looking at the gap, how do you determine what the like desired amount of water would be for a particular area? Like, you know, where does the ceiling come from?
Yeah, so what we do in our modeling effort is we have information on what is the domestic use based on population, but also there's many observations there's observations of and reported values on domestic use, for example. So we have that per country in the US, can know how much any county uses in terms of domestic water use, industrial water use. For irrigation, it's a little bit more tricky because there we also look at the climatological extremes. So if it's really dry, then farmers are more likely to irrigate more. But there are certain requirements that you can already know that a crop has in terms of water. So that is how we dynamically allocate that water. So for some sectors, we have a number, like this is a number because there's so many people that use on average, 120 liters per day in this city. For industry, we also have the numbers also going back 40 years. So all that reported data is there. And for irrigation, we can actually do it a bit more dynamic. And then we compare it also with the reported values. So we can do some validation of how accurate we are. And we can also see, for example, the trends on that unsustainable use. You can also observe some of the trends with satellites, how much the groundwater is depleting. We make an estimate and we can directly compare that with satellite imagery as well to get also some insight. I mean, it's nice to make a model, but it's also very well to know how good it is and where it does perform very well. So that's what we try to do in terms of benchmark. Yeah.
All right, so I didn't catch that. Did you say this is, can we query this now, or is the data available only as like the world?
Currently, the data is mostly available as the world, but if you want, you,
So we would have to like message you to say, hey, I'm interested
Yeah.
in this area, can you?
that's currently the easiest way. And the idea was go next year with where you can query for specific places yourself. But I mean, it's fairly easy for us to do. So if you give me coordinates, depending on my response time, but you have it quickly, yeah.
But you can already now with this map, you can at least at a sub-country level, because we have so-called water provinces, which is sort of an overlay of country administrative boundaries and catchment boundaries. So those are areas where, you know, water is sort of a unit that you can transport and jointly use. And for these water provinces, which are at a higher resolution than countries, you can already get the demand for the different sectors, how it develops from, say, the 1960s to now, as well as the total water gap, how it develops. So that's already in the map.
Stephanie, do you want us to go to,
There's one
maybe the
there.
hotspot?
There's one hand raised there.
My name is Amy Meyer, I'm a freelance recruiter in California. I apologize, I came in late, so if you already answered this, then don't say it again, but I'm curious to hear how you think mapping will help us overcome the water shortages, the premise of your roundtable here.
Yeah, that's a really great question. I mean, I think it comes down to me, my thoughts are the basis of any action is information. And people can't act if they don't know that it's happening. And this is just such a powerful visual tool to be able to go on and see how the water gap has grown from 40 years ago until now, and how, you know, a lot of areas around the world are in bad shape. And I think that really one of the really powerful things about the map is it operates at the global level. And you can see how this water gap has grown and how it's a global issue, but it also goes down, like Marc was saying, down to water provinces. And you can actually put in your own address into the map and see where the water gap has grown in your community. And that'll differ for people around the world. It'll differ if you live in the Colorado River Basin versus you live like I do on the East Coast. You know, the water gap, that growth will differ. So I think having that personal aspect will really inspire people to realize this is real in their own lives as well. It's a global issue. It happens in these hotspots around the world, but it also will affect people in their day-to-day lives. I think that's one way that it really will inspire some action. And another way is the science, the data behind it, and arming journalists and scientists around the world with the data to be able to report on the issues in their own communities, and then also fully understand from a data point of view how this issue is grown and manifested.
And there's one thing I'd like to add, because for all those hotspots, we actually also did that, as I said, that analysis in comparison to local studies. And for there, we can identify also drivers, pressures, and solutions they locally implemented. So in that sense, it's actually, there's a poster this after this presentation at 3 o'clock today, where actually we can see per hotspot, like what are the driving causes, but also what people have been locally doing so far. And we can see some of those hotspots have very similar processes going on, and you can actually learn from each other. So I think by connecting also what's going on, for example, here in California and how things are going in the high plains, what kind of solutions have been taken, their policymakers can also learn from each other. And we as scientists as well, because we see how this process matters in this region more than in the other region. Yeah. And I think that's the poster or the presentation I was talking about.
Yeah, 3 and Moscone West 318, 3008. Yeah.
I also, you might not have caught, there's kind of two main sides of the freshwater initiative. One is the World Water Map, and the other is the series of RFPs that we'll be launching for grants in education, conservation, and storytelling. So we have our 10 storytellers now who are working in tandem with this map to investigate how it looks on the ground and to reach people with really powerful visual journalism to inspire change. And then we'll do the same thing with actual conservation, community-led conservation grants that will work in tandem with the map. And I think we can go, we could, oh, sorry.
Sorry,
Yeah.
I forgot to introduce myself. I'm Jen Yeltsin. I have a question about your data. So I know there's probably a lot to this, but I imagine that these data were collected by various different agencies and such. So how do you compare like one country's standards ways of collecting data versus another country? Like, are these actually comparable between countries?
It's a very good question. It's really, that's one of the Achilles heels of the socioeconomic data, because they are, collected by organizations like the Food and Agriculture Organization. They have this about water use, and the way that water use is estimated. Some come out of models, some are census data, some are really metering. So it's a really different quality, and that is something we have to work with in these global. So there is a level of comparison, but there is also sometimes it's apples and oranges, but we have to live with it. It's the best we have at this point. Yeah. But we only use those reported data as validation because we actually calculate the water demand in a uniform way across the globe based on socioeconomic data. But where the reported data on water use, they are often very different per country. Still, we use them as a sort of weak validation of how good we do.
I have a question. Kash Patel of the Washington Post. I'm looking at the World Water Map website that you were showing. How often is the data updated? Because this goes to 2019, and what's how small of increments can I ask you for? Like monthly, yearly, or what?
So internally, as Marc already said, within the model, everything runs on a daily timescale. So in theory, if you want a specific year, that's available. I think on the website it's now yearly, the data we push, because it's mostly a data volume issue. Once we go to the expert version, we're actually looking at to see if we can also get finer resolutions in terms of temporal data, because then people can select regions to query rather than getting the whole world as a one go.
But you mean beyond 2019, I guess, or not?
Yeah.
2020, so of course now in 2023, yeah.
Yeah, that's always a tough one, because you want to have the consistency as well. So you want to make sure that the data for that entire period is consistent. So some of the new real-time data doesn't have the same quality as the latest data. We can now go to 2022 if we want, but yeah, 2023 is different. So that's always a bit of a monitoring versus analysis kind of issue.
When would you expect the 2023 data to be?
Yeah, that will be next year. If I don't know. I don't want to put my hand in the fire.
No, but the thing is that we're making this expert version. At the same time, there's also going to be an update of this one, which is a version that is more, say, for the general public, and then we also going to add at least future projections, because we have future projections. We've published about it, and we have them in our store, but we haven't implemented it yet. Which means that and of course these are projections, but so once we do an update, we would likely go as far as possible using the current data, and then add a future projection, so that you have a timeline from, say, 1960 to 2100. Taking account, of course, depending on the scenario, it's going to be bad or worse into the future, obviously. But that's going to be added also, hopefully in the course of next year.
I'll ask a question. I'm Liza from AGU Communication. So I imagine there were many hotspots that were not a surprise. Were there any surprises that you saw when you?
Now there were some hotspots mostly in Asia, not like the obvious one like India or Northern China plain, but there was we have hotspots in Japan, for example, where you also see but that's mostly industrial water use that has been popping up there, which is not necessarily always on my. We always think of agriculture as the big driver, so you definitely see those areas popping up. But sometimes we have regions where other things play a role, and then it's not the obvious, the obvious thing popping up, and that is actually what I like most about this, is that we get it from the numbers, but at the same time, then we look at the local studies, and we see that it's confirmed, but not necessarily on my, on the global radar. So I think that's
Yeah, the hotspots that were identified were those with a significant water gap according to our analysis. Plus, and that's the work of Myrta, she found a sufficient number of local to regional studies that were also mentioning that there was an issue there. So that those two together. Right.
Converging.
Yeah.
Yeah.
From different data,
Indeed, yeah.
different.
Yeah.
Studies.
So we have a question from Liz O'Connell online, writing for Frontier Scientists. She says, history should be important to this effort. For example, the Salton Sea in California was formed when a dam to divert water from the Colorado River to California was breached. Today, the Salton Sea is not a happy place. Will considerations be made in moving water by paying attention to some of these examples?
So the water diversions, I guess.
Yeah.
No, you might.
So what we, in terms of a modeling effort, like, I hope that's what she's referring to. We don't implement the diversions as of now, and that's mostly because the data is most around the world lacking. There's a good data set now for the US that we're currently implementing to make sure that we have the existing diversions in there. But globally, it's a very difficult effort to make, unfortunately.
Yeah. Yeah, but this is a big on the wish list, but we are dependent on other scientists that take the effort to map out these features and create basically space-time maps of when these features were. We have it for the dams actually, but not for the diversion. So that is big on a wish list. But we have one student now that's actually focusing on a higher resolution version of the model for the US, where we do have this information. So that's being added now.
Jen, yeah, I'm curious, does the mapping that you've done, is there advancing? Did you make any advances in the mapping technology here, or is this really a data, like, we've now made like lots of advances in the data? Or did you do anything new with the mapping side of it?
Ooh, that would be a question for the mapping people.
Yeah, I mean, to the best of my knowledge, we did not do anything new with mapping. I think this is the first time something like this has been done. And I'm thinking about the actual like technical mapping and cartography. I'm not sure we did anything different in terms of the cartography. But I think this is the first time that an effort like this has been done to map every drop of water around the world in an interactive way, where people can go on and put in their address and see how that's affected their local communities. People can zoom out and see how it's affected the whole world. To the best of my knowledge, it's the first time something like that's been done. We have cartographers at National Geographic who would probably pull their hair out if they heard me say that. Because they would want to dive into the very technical aspect of it. So.
Like, I know a lot has been done in the past like decade with online maps, right? Like we went from static maps to like all this great interactive stuff.
Yeah.
I'm sure they're working on.
Like what's
It's getting, there are different other organizations that also take that step. We also work with World Resources Institute. They have a risk mapping. They're more static maps, not say the whole timeline. So they basically look at 2 or 3 instances in time. So that's a little bit different. And they also have another audience. It's more towards companies and the risk profiles and so on. So there's a thing by the World, the World Wildlife Fund. So there are other organizations do that. But I don't think what is new here is we speak to the general public more. I think it's also more pleasing visually, I think, more interactive. But like I said, I don't want to insult any cartographers, but I don't think there is revolutionary technology here at play when it comes to mapping, to be honest.
Do you know if there are any plans to add layers to the map at all? Like how to compare different?
Yeah, so that's this expert version. So I think we want to keep this tool as simple as possible, because this needs to be, it's also integrated into sort of a, actually a little bit of a background story, teaching people what this water gap is and how it works and so on. So it's really speaking to the general public more. Whereas, you know, if you have more peers, our peers, or data journalists or journalists that want to get data behind their stories, then we want to make this more expert version that allows you to do simple comparisons. So, you know, what is the change in the water gap between this for a given country between 1960, the period 1960, 1980 and 2020, 2040, and make basically visuals of that. That's the idea. So that adds all the layers, because if you look at the data, there's much more in the data set. So there's not a water gap, but there's also this discharge, there's storage of water in the soil. There is the amount of evaporation, the actual water volumes used by the different sectors for every time step, the discharge in the rivers, water levels. There's a lot of stuff, groundwater depletion. There's a lot of stuff in there that is now uses basis for calculating the water gap, but it's underneath. So what is under the hood is going to be more visible in this expert tool.
What about like land use changes?
That's actually in there. I mean, because when we do the simulation from say 1960 to now, land use is changing in the model. So we see expansion of irrigated agriculture, we see dams being placed, all these things are in our model. So are also therefore in the layers.
Along those lines, at what spatial resolution do you run the models?
Currently at 10 kilometer pixels at a global scale, yeah. We can't for per visual, we can go to 1 kilometer. At the moment, we're currently build benchmarking that, so that's really a science project that I'm not want to put out already before benchmarking it with observations. But 10 by 10 kilometers really is approximating like that you can go to fine resolution. So that's the base data is at that resolution.
Yeah.
Soil moisture and so on comes from satellite data.
Soil moisture is simulated within the model, so taking those precipitation, evaporation, and temperature. We do have, I mean, in scientific journals, we have benchmarking of that product with satellite data. But that's, yeah, I don't think a lot of people are, there are people, there's an audience for that, but probably outside in Moscone West. But no, so that is something that we always do, because especially if you go to the future, if you don't have trust in like the past, how your model is performing, and also know its weaknesses, then it's very difficult to go out into the future with confidence. Yeah.
Last questions from the room or online?
Nothing online. If I may, I am Becca with AGU Media Relations. I'm curious about how this work intersects with sort of all the attention and work on dam removals right now in the US and abroad. Both for, so my questions would be like, A, how sort of flexible or responsive will this tool be in being able to reflect those realities as they're changing on the ground? And sort of a follow-up, like, could this actually be a tool for helping track dam removals and the associated water changes?
The last answer is no, because you have to, if you want to track that, you need remote sensing. But if that dams are if we simulate from the 1960s to now to 2019, we add consecutively the dams that have been erected. Small dams that are now being removed are so we can take account of dams being erected, so we can also easily remove dams again from the simulation. So we can do that. Obviously, a lot of the dam removal is smaller dams up in the upper reaches, and they are not in this model because it's a global model, and we don't have the very small dams in there. So yeah.
Let's go.
Okay.
Well, thanks so much to our panel from National Geographic and Utrecht. We have this recorded and on AGU's YouTube channel for everyone to watch publicly later today. And for the journalists, we'll make the slides and also these other resources, links available to you in the press exchange. Thank you for coming today.
Thank you.
Our next event is NASA's Open Science team. They'll be talking about how they're trying to make science open to everyone. That's at 2:30. It's just the media availability here in the press room.
Can I say one final thing?
Of course.
So our RFP, request for proposals for our conservation grants, is open right now. It will close in March. So if people have community-led or community-reflected conservation solutions they'd like to apply for, please check out our website.
Great. And I will plug just briefly for the water folks in the room tomorrow, we have roundtables on both human and animal-made dams. We have a roundtable on beavers in the west and beyond. They help or hinder. And then we also have a roundtable on both the science and sort of ethics and societal end of dam removals, and that's focused in the US. So join us there. And now we're be done.
Good.
Thank you for that.
Thanks,
And
thanks.
then also, I'm with the comms team at Net Geo, if you have any questions or want to connect with my brilliant colleagues to help you, we hope to see you have reach for more.
We maybe put the hotspots slide just one more time.